Rolling, and we're back for another video on home loans and Year 12s. This relates to task 3 of the assignment. Let's have a quick look at task 3 here. Banks and lenders often claim that as an alternative to paying the nominated monthly repayment, payments exactly half of this amount made each fortnight can reduce the term of the loan by up to 5 years. So we need to justify the above claim by creating two loan repayment schedules side by side, one with monthly repayments and one with fortnightly repayments. So we assume that interest is calculated monthly for the monthly schedule and fortnightly for the fortnightly schedule. And we can use the data from task 1, that should say from task 1, but we may need to modify some of the figures. Okay, so let's go back and look at task 1. So task 1 was just looking at a straight up and down home loan. This example here, $450,000 over 25 years. And graphically, this is what it looks like. So we're going to try and save some time here. So instead of paying it off in 25 years, we want to try and pay it off in close to 20 years. And just by doing a simple thing where we, instead of doing monthly repayments, we do fortnightly repayments. Okay, so let's see how this is going to work. So I'll start by copying this sheet here. So if I just click up in the top left corner here, I can highlight the whole sheet. Control C and then Control V into another sheet over here. So I might just make this a bit smaller as well. Let's go. There we go. Now, what I'm going to do is modify this one. I didn't want to do that. I just want to modify this one so I can still have my monthly schedule here, but I want to do a fortnightly schedule over here as well. So I'll just try and bring it all in a bit so we can try and have it all on one view. So I'm just going to tighten this up a little bit. Maybe not that much. There we go. So this is looking at the monthly scheme. Now if we do a similar thing here for fortnightly, so we can have pretty much most of this is going to be the same. So yes, the amount we borrow, the interest rate will be the same, but this is monthly. So here we're going to, instead of dividing by 1200, we're going to divide by 2600 because there's roughly 26 fortnights in a year. If we want to check exactly, we could say there's 365 days in a year, and we can divide that by 14, and we get that many. So it's about 27.1, okay, but 26 will do for the purpose of what we're doing here. So this is a fortnightly rate over here. This is a monthly rate here. 25 years still. Well, actually, you know what? We don't know. So when we do work out, we're gonna have, this will be the unknown. So we're gonna have to figure out how many fortnights will it take to pay this loan down if we pay fortnightly, because by paying fortnightly, you end up paying a little bit more. Now the repayment is not, we're not using the formula here because we don't know how many terms it's going to take. So we're going to say it's the monthly repayment divided by 2. So in here we'll just say this divided by 2. So yep, so what we're saying is if we pay half the monthly every fortnight, we're going to pay it off sooner. And why does that work? Because there's not exactly 2 fortnights in a month. Okay, there's actually a little bit more than that. There's about 2.167 fortnights in a month. There's not 4 weeks in a month. There's about 4.33. Okay, and to verify that, we can just do things like this: 365 days in a year. So if we divide that by 7, it tells us how many weeks there are in a year. And if we divide that amount by 12, that tells us there's about 4.34 weeks in a month on average. Okay, and if we go further, we can say, well, let's divide that by 2. That didn't work. Divide by 2. So we get that. So we get about 2.17. Okay, 2.17 fortnights in a month. There you go. All right. So here's our monthly schedule. We'll keep that as it is. What I'll do is copy this, just the structure of it, paste it over here, Control V. Now, I'm just going to reduce the font size because I want to bring this all in a bit. Okay, that's better. Okay, all right. So this is a monthly schedule. This is a monthly schedule. Over here, we're going to do a fortnightly schedule. Fortnightly schedule. So the present value will be the same at the start. So we'll pull our numbers from here. The interest rate, so it's going to be a fortnightly one. So we're going to say this multiplied by the fortnightly rate. And the repayment will be this one here, which is half of the monthly. And just make sure we use the dollar symbol. You might recall from the last video that using the dollar symbol fixes the cell in that formula. Do the same here for the interest rate, and the balance. Well, that should be the same, and we'll come to that later. So I think that's right. So if I drag that down, that's all good, and just make this a little bit bigger. Okay, so this will be. This is fortnight, so N represents fortnights here. Now, to give you a rough idea, so we have 25 years divided by, 25 times by 26. That'll tell us how many fortnights we have in 24. So it's about 650 fortnights in 25 years. Now, we're hoping to pay it in less time than that, but it gives us an idea that we need to string this schedule down to about 600-ish fortnights. So here I go. And in fact, what I might even do is just do this here first. So we'll go beyond 600. Okay. That should do it. And what we can now do is we've got the formulas correct in here, hopefully. So if I double click right here, that should generate values for all those cells, and we're going to go down and check. Now, what we're checking for is we want to see at what time does the balance hit zero. So if I go for a walk down here, it's going to be around the 600 mark, I predict. Okay, I just went too far then, so I'm coming back up. Okay, yep, oh, okay. So let's have a look. Here we go. Somewhere around here. So we can see about the 570 mark, it looks like, yeah. So what I'll do is highlight that stuff there and delete it because that's irrelevant, that stuff there is. So I think there's clear contents. Done. Now, so if we look at this here, you can see that we actually need to make one more repayment, just looking at that actually. So let's just drag it down one more because we've still got $53 to clear off the balance. So just drag that down one more. There we go. Now, that last repayment can be adjusted, and the last repayment will just be what's owing plus the interest that is compounded on that amount, and there we go. So we're down to zero. Okay, brilliant. Now, just going to remember where this is, 579. Okay, so let's come back up here for a second. Now, over here we had the total interest paid for the monthly schedule. This is a monthly schedule. This is a fortnightly schedule here. So let's do similar calculations here. Let's figure out. I'm just going to delete this stuff now because that was just doing some rough calculations before. So let's get our total interest and our total repayment for the fortnightly schedule, and we'll also work out what the time is. In fact, we can do that bit as well. Let me do this one first. So total interest paid is the sum of this whole column here. Okay. Yep. And the total repaid is the sum of this column here. There we go. And we can do a quick comparison here. So you can see in the monthly schedule we paid 250. Well, we would pay 253,000. In the fortnightly it's 218. So there's a bit of a saving there. You can see the same saving will apply to the total repay. Okay. One more thing, a couple more things, sorry. So let's work out how long this took. It was 571 fortnights, wasn't it? 571 fortnights. Yes, indeed it was. So 571 fortnights. So let's put that in here. 571, that was fortnights. Just so we know that means fortnights. This was annual. And so up here we had annual, and this is months. Okay, now let's convert fortnights into years. So over here we're going to say this divided by 26. And what does that tell us? It's about 22 years. 22 years. Okay, so just as we did with the monthly schedule here, we had the present value plus interest. We'll do the same thing over here with the fortnightly. And so that means we can do our graphs and we can compare these two, because we can compare them by the numbers and by the, the spreadsheets, but really a graph is the best way to compare them, because we get an instant look at the difference. So so over here, this will be the present value. So that's the total that we pay. Now, let me just do this properly. So it's a total that we pay over the 571 fortnights. And then the cell below that will be looking at that amount minus the repayment. Done. Okay. Yep, and that should get to, not quite zero, but it'll be basically one repayment away, or close to one repayment away. And we can see that, yeah, indeed, the last, yep, so it's one, yep. Okay, so now we're ready for graphing, so we can really compare these two. By the way, the question, the task was to show that we could save up to 5 years, Now, this is not showing a savings of 5 years, it's showing a savings of about 3 years, okay, which is still a good amount of time. And the important thing really is if you're saving time, you're saving money. Okay, so 3 years equates to, if we look at the difference here between these interest values here, what do we notice? We'll just do a quick calculation of the difference there. You can see it's about 35,000 saving. Okay, we say, well, it's not the best colour, is it? Same one. Just go back to there. So we're saving 35,000 by paying it off 3 years sooner. Not bad at all. Right, last step, graph. So I can just use this graph here. No, I'll create a new one. So first thing is, let's just do control. In fact, let's see if I can get this one as well. And we'll just graph. So I'm going to try and graph two series at once here, and it worked. Brilliant. Okay, so, whoops, come back. So I'll move that chart, move chart to its own sheet. This is task 3, task 3 plot. Done. Now in here, so this is the monthly schedule we're looking at. So let's add the I just realized something. Let's not do it this way. Sorry. Let's actually, okay, the problem we're going to run into here is that the units of time are different. So this is in months, this is in fortnights. So we really need to reconcile that so that we have the same unit. So So what I might do is convert everything to years. Okay, so insert. So we'll convert to years. Now, so if we start with the monthly one, we're going to divide each of these months by 12 to convert it to years. And for this one here, it's fortnight, so we're going to divide by 26 to convert that to fortnights. So now we have a common time scale. So you can see 1 year here is that much, but 1 year here is that much. So 26 fortnights is 1 year. Okay, so that represents a year. That represents a year. Okay, all right. Now let's graph it. So Command Shift down, or if you're in Windows, it's Control Shift down. Command Shift down, and Command Shift down. Right, so let's graph that, scatter, and move that chart to its own sheet. So task 3 plot. There we go. Now let's add a couple more series. So this, you can see now this is in years. This time scale here is in years, so it goes up to 25 years. Now we're going to add the fortnightly data to that. So series 1 was PV monthly. Series 2 is PV plus interest monthly. Yep, now we're going to add series 3, which will be PV fortnightly. And so here we go. So the X values, let's grab the X values. Where are we? Back over here. So the X values are essentially all of those. Oh, won't let me. Oh, let's just do it this way. So I'm going to have to do it this way. All right. So we need to highlight all those X values, which are which is the number of years on the fortnightly schedule. Okay. There we go. So it's about 22, rounds up to 22 pretty much. And the Y values will be the present value. Okay, got away from me there. So we're just going to there. Okay, let's see what happens. Good. So, so the blue line is the present value for the monthly schedule, and it's paid in 25 years. The green line is the fortnightly schedule for present value, and that's paid off in 22 years. Now let's put the present value plus interest one in there as well. So we're going to add one more series, and then we're done. So add another one here. So this one is PV plus interest. Hang on. PV, going well. PV plus interest. And I think the X values should be okay. We'll see what happens. I'll just try and grab the Y values and see if it plots it based on that. So the Y values, it's this column here. Here we go, here we go, here we go. Okay. There we go. And okay, and no, I didn't like that. So we're gonna have to fix that up. I'll fix that up. It's done it based on the fortnight, so I'm gonna have to enter the X values for that one. And let me just fix this title up as well. PV plus interest and fortnightly. Spell it right. Fortnightly. So the X values are essentially those values there. So in years. And here we are. So, right there. And I think we're good to go. Let's check this out. All right. So, the purple and green lines, they represent the fortnightly schedule. The red and the blue for the monthly. And you can see the time saving there. Now, if we compare these two linear plots, you can see that the red is for the monthly and the purple is for the fortnightly. So the difference here, that's the interest that you save by doing it fortnightly, by paying fortnightly. So that's a good graph for comparing. So you can see the present value starts at the same for both, but you have the savings in time here. So there's a time savings of a time saving of 3 years. And then up here you can see the interest that's saved, which we worked out before to be about 35,000. Okay. So I think we're done here. Go back to the task. We have to discuss why this saving in time and money is made possible. So you need to talk about, that how many fortnights are there in a month? Because really, what we're doing here at the start is we're just dividing the monthly repayment by 2, which is kind of a rough calculation to say, yeah, there's about 2 fortnights in a month. But actually, there's a little bit more than 2 fortnights in a month. So we just need to talk about that in validating why this happens. So you end up paying more money. Ultimately, you pay more money sooner by paying fortnightly, where the amount that you pay is half what the monthly is. And it's the idea of, the more money you pay and the sooner that you pay it, the less interest you pay, which means the less you pay overall and the less time it takes. So it's there's a clear correlation between time and money here, okay? And it's all to do with compounding. The only other thing is, what do you have to do here? Interest on home loans is calculated on a daily basis. Discuss how your assumptions of monthly and fortnightly interest calculations affect your results. So back in task 1, you probably would have talked about some of those assumptions on, banks compounding daily versus, our spreadsheet compounding monthly. The more often you compound, the more the money builds up. So, we can say here that by doing it fortnightly, by doing a fortnightly compounding, you're actually, in a way, you're charging more interest. So neither of these models are accurate in the sense that, banks really do it on a daily basis. Here we're doing it monthly, here we're doing it fortnightly. But the other factors such as, we have a fixed rate, we're only paying the minimum monthly repayment. Those things are probably bigger factors in how long it takes and how much you end up paying. So good. Hopefully this has been a good lesson for you in just looking at home loan annuities in general. It's quite interesting because you get a feel for how much money that banks make in interest, and it's obviously it's a long-term commitment. We're looking at 20 to 30-year commitments here. If you're in a position where you can afford to, then for sure you would pay more than the minimum monthly repayment and hope to pay it back in a much shorter time than 20 to 30 years. Rightio guys, that'll do for now. Thanks very much and enjoy.